everyone. I am so excited to be here today to talk to you all about decorators. I picked this topic because I think it's really relevant to Angular development, right? As Angular developers, we use decorators, the built-in ones, all the time. We use input and output decorators for automatic data binding. We use host listener to listen for events and react to them. We use component to pass metadata to Angular to tell Angular how to build our component, what selector to use, or where the template file is. And in the case of ngModule, almost the entire file is a configuration object that's passed into that ngModule decorator, and that tells Angular how to bundle our application. Let's be honest, though. We don't necessarily need to know a lot about decorators in order to use the built-in ones in Angular. But today, we're going to level up our TypeScript and JavaScript skills and learn how decorators work. I'm sorry. Oh, OK, just a delay. Before I jump into talking about decorators, though, I want to clarify exactly what I mean when I say decorator, because the word has at least a few different meanings in programming. So one is the decorator pattern. And this is a pattern that is outlined in the famous Gang of Four design patterns book. And it's a pattern that's used in statically typed languages such as C, C++, or Java. And it is used to add behavior dynamically to an individual object without affecting objects of the same class. So this is very useful in those statically typed languages, but not what we're going to be talking about today. We're going to be talking about the language feature, which is available in Python and TypeScript and JavaScript a little bit. We'll talk about that in a little bit. And this is a language feature that allows you to add functionality and metadata at definition time. So the important thing to take away here is that the language feature is not an implementation of the pattern. So what is this TypeScript language feature all about? Well, it allows you to observe, modify, and replace class declarations and members. You can attach decorators to classes, properties, and methods on those classes, accessors like get and set, and parameters on your methods. Todd Motto wrote an awesome article about Angular decorators that I highly recommend. It's in my slide notes. And in it, he says, in Angular, we use our class decorators to express intent for our classes. We express that intent before we even put any code inside of our class definition. And I think this is a really smart insight. We can use decorators to add some small helper functionality or to create a base for our classes to completely replacing what we're decorating. Another way to think about it is that it's a way to provide annotations and a metaprogramming syntax for class declarations and members. And this is possible because, as you'll recall, functions in JavaScript are first class, meaning that we pass them into other functions as data sometimes and transform them, which is exactly what we're going to do with our decorators. So as you probably know by now, we can use decorators right now in TypeScript. But if we're creating a new TypeScript project without Angular, we do need to specify these two settings in our TypeScript configuration file. Experimental decorators needs to be true, and emit decorator metadata also needs to be true. And this is because the decorators are currently a stage 2 ECMAScript TC39 proposal. So the ECMA TC39 committee is responsible for evolving the ECMAScript standard and authoring the specification. Stage 2 is the draft stage, where they precisely describe the syntax and semantics of the language. So we can't use decorators natively in JavaScript right now, but we can with the help of transpilers such as TypeScript or Babel. And in this talk, I'm bouncing around a little bit between talking about TypeScript and JavaScript, and that's because a lot of the ideas that we're talking about today are applicable to both. Decorators are kind of a fancy syntax for higher order functions, and many of the ideas regarding how to use them are transferable between languages that use higher order functions. So let's get into some examples. In these examples, I'll show you the decorator definition and then how it's applied to a class or class member. So to define a decorator, we just create a function with a particular signature, and that signature is going to change depending on what we're decorating. In this case, we have a class decorator, and class decorators accept a class constructor as an argument. This decorator seals the object's constructor and the constructor prototype, which prevents new properties from being added to it and marking existing properties as non-configurable. We could return a value from this decorator, and that would replace the current constructor, but in this case, we don't need to. When it's applied, we can see that it's using that @ sign as a prefix, and then it's placed right before the thing that it's decorating, in this case, the bear class, or sorry, raccoon class. Here's another example. This time, I have a method decorator, and you'll notice that it has a different signature than the class decorator that we looked at. Here, we're passing in 3 arguments. There's the target, which is our bear object, and then the property key, which is the name of the method that we're decorating. In this case, it is hibernate. And there's a descriptor, and that is an object that gets passed in, and it describes that property, and we'll talk about that in a little bit. So the purpose of this decorator is to display a warning when a deprecated method is used. We return an object here that is going to replace our descriptor, and we use object destructuring to copy the properties that were originally in the descriptor, and we're just replacing the value with a wrapper function that is going to put in that console warning that the method has been deprecated, and then it just calls the original arguments on our original method. So here's another example from the TypeScript decorators documentation. This one is a parameter decorator. And in Angular, we have quite a few parameter decorators available to us. And they're specifically for constructor arguments. So inject, self, skip self, optional. But you probably wouldn't use those as much as class and method decorators. So this is kind of a dense decorator. And we don't need to necessarily go into all of it. But conceptually, what this decorator does is it adds a parameter that we're decorating to a list of required parameters. And then it's paired with a validate decorator that's put on that method. And that will throw an error for any parameter that is not used in the method at runtime. If you're interested in seeing the full implementation of this, you can check out the TypeScript decorators documentation. But the reason why I included it here is because this uses the reflect metadata API, which is an experimental metadata API. It's a polyfill. And this adds additional design time type information that can be exposed at runtime. So this is very useful when you're creating your own decorators in TypeScript. And something that's kind of interesting is I did this talk for my coworkers a few days ago, and they have more C# experience. And they were saying that it really reminded them, this particular use case reminded them of data annotations in C#. So if you have that background, you might be able to draw that parallel as well. So verifying type information at runtime is also a great use for decorators. So I want to take a sidebar here and talk a little bit about property descriptors. These are made available to us by JavaScript, and they describe a property on an object. This data is created for each property that you create on an object, and the defaults are different depending on how you create that property. So with assignment, like regular property assignment, or if you're just creating an object literal, all of these descriptors, the configurable, enumerable, writable, all of those default to true. If you're using object.define property instead, those all default to false. Now, if you're not familiar with these, I'll just kind of go through them quickly. Configurable is whether you can change the property descriptor or whether you can delete the property. Enumerable means, does the property show up in an enumeration of the property, such as in a for-in loop? Writable is if the value can be changed with an assignment operator, and then the value is just the associated value. So this is good background info for creating your own decorators, because many implementations of decorators deal with property descriptors in some way. These descriptors give you a more fine-grained control over your object properties, and they're in vanilla JavaScript. So I'm going to do a demo now. Cool. So I'm going to do a demo now. And what I want to show you guys today is how to create a simple method decorator. And this decorator is going to decorate methods that return data. So return data from a remote data source or even locally. And they would be attached to this method and completely replace that method with a observable wrapped error instead. And what this allows me to do is go into my components that consume that data and just fortify them and make sure that they are dealing with that error as gracefully as possible. So whether that be just showing an error to the user or doing something else to replace that data. So I have this project available on StackBlitz. It's a very simple Angular project. It's in the slide notes if you want to play with it yourself. It's very simple. It just has one component, my app component. And inside this component, I have two properties. I have a property cities that's going to hold my observable that has an array of strings. And then this error message property is going to be populated with an error if there is an error produced. And then when I init my component, I'm just assigning the result of this getCities method from my city service to that property. If I go into my template here, I can see that I am using the async pipe to subscribe to my observable, and then I'm just looping over those cities to display them to the screen here. And right below, I have a block that will only show up if that error message property has something in it, and that will show my error message. So that hasn't been hooked up yet, but we'll hook it up in a second. If I go into my city service, I just have one method here, getCities, and that returns an observable wrapper around an array of strings. So I'm holding my data locally here, but you can imagine that this would work the same way as you would like normally get data. So if we have like get string array, that kind of thing. So it works exactly the same way. So I have this observable that I'm returning here. If I wanted to return an observable just brute force, one way that I could do it is just commenting out that return statement and just returning throw error. And that does, you can see it does replace my, I'm not getting my data anymore. But this is kind of like messy, right? Like we don't want to be always commenting and uncommenting code. Like if I do that, I'm probably going to commit it and then cause a huge problem. So, so it's easier if we can just like turn that into a decorator. So I have some decorators prepared here. The first one that I want to show you is this regular method decorator. You can see that the signature looks quite a bit like the method decorator that we saw earlier, deprecated. And so we're passing in a target, a name, and a descriptor. And the first thing I'm going to do here is just log each of these things out so that we can see them in real time. And then I am using the same technique of returning a plain object that copies over the original descriptors and then just replaces the value with a new function that's going to return an error. So let's see what this looks like when we apply it. I will uncomment that import statement, and then I'm just going to apply my decorator right on top of getCities. And we can see even though we have our original method here, we're not getting our data anymore. And if we go into the console, we can see our console log error, or console log. So we have this object that this represents our city service, and it has our getCities method inside it. And then our second argument is getCities, so that is just a string that is the name of the method that we're decorating. And finally, we have our method decorator, sorry, our property decorator. There's so many D words. Property descriptor. And that has configurable, enumerable, and writable, and our value, just like we saw before. If we come into our app component now we can log that error. since we have that there. And we're going to do that by just attaching a pipe and creating a side effect here. And when we get data, let's see, when we get data, we want this .error message to be undefined, because we don't want to see anything in that variable if we do have data. Otherwise, we want this .error message to equal our error. And when we do that, we can see our error message right here. So everything is working the way that we expect it to. The next variation that I'm going to show you here is passing in an argument to our decorator. So it's totally possible to pass in an argument. You just need to rearrange things slightly. So you can add an argument by changing our exported function to instead be a decorator factory. And what a decorator factory is a function that returns the expression that is called by the decorator at runtime. So this is what that looks like. We are passing in a message that we want to be like a custom error message. And that's the only argument for this piece. And then we're returning an anonymous function here that has the same signature that we saw before with the target, name, and descriptor. And then everything else here is the same, except that we are passing that message into our error observable. And if we switch out city service, if we switch out to the second decorator, now we can see that we are getting an error here because it expects an argument. And if we put in, this is my custom message, we can see we're now getting that inside of our UI. So let's see. Let me get back to the. There we go. So I didn't have time to go over tons and tons of examples today, but here are some other examples of ways that you can use decorators. For logging, you could log when something is instantiated. Telemetry and performance, you can create timers with decorators. You can validate and verify type information. Memoization is also a very common use for decorators. You can check if a required parameter is present, and then just changing the property descriptors, like we talked about before, is another good one. Another just word of warning is to generally avoid code smells. I thought of, while I was creating this presentation, lots of ways that I could troll my coworkers with terrible decorators that replaced and did all kinds of tricky things. But as always, it's always good to be simple and straightforward. And I have lots of great resources here. One that I want to call out is the core decorators.js repo by the awesome Jay Phelps. And I found lots and lots of great examples of decorators in there. But a word of warning, it says in the repo that it's not completely compatible with TypeScript. So maybe just a place to find good ideas about how you can use decorators. But all of these resources are really great. And that's all I've got for you. Thank you so much. You can find me on Twitter. Yeah. Thanks.
Yeah, I love decorators. Yeah. I've been hoping,
I knew you were going to say this, too.
Of course you knew I was going to say that. I think I gave a talk, 3 years ago, and I was talking about decorators? Yeah, they'll make it in JavaScript someday.
Yeah,
someday. Yeah.
I'm actually glad Nicole mentioned the spec, too. That's always important, too. Eventually, we'll see this.
Yeah.
We'll see it in native JavaScript, so
yeah.
Let's hope we do.
That's what's super exciting.
Yeah.
I wanted to pick something that was very relevant for because I think as Angular developers we are very dependent on TypeScript now. Yeah. I think
it's not a bad thing.
It's not a bad thing,
awesome.
But I think there's other parts of the community that kind of give us flack for it. Have you ever heard that? Some people some people are very just critical of the way that some developers like really cling to TypeScript. And I think it's really important to know how it works under the hood too. That's the only thing, right? Like you can love TypeScript. It's awesome. Like I love TypeScript. Ooh. But knowing how it works under the hood is also super important.
I think that goes with anything too. Is like anytime like I think of a framework, like whether you're using Angular, React, Vue, whatever framework.
Yeah.
It always comes down to like you should know the JavaScript behind it, and that's what I love about the Decorators talk, which was great. So,
Awesome.
Yeah.
Awesome. Thank you.
Yeah, I did not know about object.seal. I knew about object.freeze, but object.seal, that's brand new to me.
Yeah. I think it's a ECMAScript 2016 feature.
You would know
It's
better than
relatively new. It's relatively new.
But I have a real question for you.
Sure.
What is your favorite Smash Brothers character? Like, I mean, you work at Nintendo, so like, you gotta have opinions.
All right, I'm gonna be real with you. I can't keep track of all the characters on the screen in Smash. But usually when I play like Link or Kirby.
Ooh, good choices.
Yeah. What about you?
I'm more of a Samus, like, you know, off stage, waiting for everybody to battle out, and then I just snipe people left and right.
Nice.
That's how I do it. But.
Yeah.
That kind of describes you very well too. And I also wanted to hear more. You sang at the Giants game.
Yeah,
I
did.
That was awesome.
Yeah,
how did that come about?
Like way back in the day, I was part of a chamber choir.
Yeah.
And we used to sing all over the place in the Bay Area. And yeah, we got the opportunity. We had a really, really awesome mentor who just like created all these awesome opportunities for us. And one of them was she was like a huge Giants fan. And so we got to go do it twice, actually.
Wow.
It was super fun. Oh no, I actually have a cold right now.
I wasn't going to make her do that on stage. That's unfair.
That's for karaoke later. She's going to show us all up.
All right, well, thank you so much. Your talk was amazing.
Thank you.
Thank you.
Yeah.
All right.